Question 1. Through the lens of a multinational enterprise with 2 remote offices connected via a high-latency satellite link, Fernandez notices that even though data deduplication is enabled on Steelhead appliances, transfer of large database update files remains slow. She suspects protocol inefficiencies are the root cause. What conceptual steps should Fernandez take to most effectively improve performance? A. Enable CIFS optimization for all file transfer traffic. B. Adjust TCP window size on the client side. C. Activate Steelhead's TCP enhancements. E. G. Fast stack selective acknowledgements. D. Deploy an interceptor appliance to offload traffic. Answer. Correct answer. C. Explanation. Riverbed's TCP enhancements directly mitigate latency effects. E.g., fast stack selective ACK by reducing round-trip acknowledgements, addressing slow start and congestion issues. CIFS optimization helps share eliminate redundant file blocks, but won't resolve latency-induced protocol wait times. Adjusting ECP window size may help throughput, but is limited by link latency granularity. An intercept aids appliance clustering, not protocol tuning. The correct approach tackles TCP mechanics to improve end-to-end efficiency. Question 2. In the context of a global retail company deploying Steelhead appliances in both in-path and out-of-path modes, Singh is weighing trade-offs. He's concerned about traffic interception reliability and failover behavior. Why might he favor an in-path deployment for critical branch office traffic? A. In-path mode avoids routing complexities and ensures traffic always passes through Steelhead. B. It allows traffic duplication for monitoring without affecting the data path. C. It enables Steelhead to forward traffic transparently during appliance failure. D. It simplifies cost configuration across WAN links. Answer. Correct answer. A. Explanation. In-path deployment inline ensures that all traffic necessarily traverses the Steelhead, offering consistent interception and optimization. If the appliance fails, in-path can fail open or closed depending on configuration, but routing remains simpler. Out-of-path requires policy redirection or fail to intercept under misconfiguration. Traffic duplication isn't the core ally here. The transparency during failure depends on bypass mechanisms. COS isn't inherently simpler in in-path. Question 3. Given the circumstances of a financial services company using Steelhead to accelerate HTTP SSL traffic, ISTA1 notices that users regularly access secure web applications but response time gains are minimal. Which underlying principle likely explains the lack of acceleration? A. Steelhead cannot optimize SSL traffic due to encryption. HTTP cache is ineffective. B. Deduplication is disabled and encryption breaks signature matching across flows. C. Steelhead doesn't intercept HTTP of SSL by default unless SSL decryption is configured. D. Steelhead only optimizes HTTP if traffic is first tunneled through the Steel Central Controller. Answer. Correct answer. C. Explanation. Steelhead can only opt to HTTP of SSL yet SSL interception decryption is enabled. Otherwise, encrypted content bypasses optimization entirely. Option A is misframe. SSL often permits session resumption or certificate caching but needs explicit decryption. Deduplication. B also fails when content is encrypted end-to-end. D is incorrect. Controller isn't prerequisite or SSL optimization. The conceptual key, encryption blocks inspection unless decryption is in place. Question 4. Among the various techniques Riverbed uses to reduce bandwidth, deduplication, compression, and protocol optimizations, O'Connor is evaluating the impact on congested WAN. Why is deduplication often more bandwidth efficient for repeating content than compression? A. Deduplication eliminates entire repeated byte sequences rather than encoding them more compactly. B. Compression only works for text, whereas deduplication works for all data types. C. Compression introduces latency overhead that deduplication avoids entirely. D. Deduplication archives all data on device, freeing bandwidth. Answer. Correct answer. A. Explanation. Deduplication works by recognizing and referencing previously sent data sequences, eliminating redundant transmission entirely. This saves more bandwidth than compression, which only encodes data compactly but still transmits it. Compression works on all suitable data, not just text, but is limited by entropy. Overhead exists, but not the main issue. Latency overhead exists on both techniques. Deduplication doesn't archive, it references. Question 5. When considering a scenario where Steelhead Mobile users connect from various ISPs to corporate cloud apps, Mr. Patel is planning deployment. Which conceptual requirement must he ensure for optimal performance? A. Steelhead Mobile clients require interceptor appliances at each ISP to accelerate traffic. B. The cloud side must include Steelhead or virtual Steelhead SOS accelerator to complete optimization. C. Data reduction only works on mobile if COS is configured on user-side routers. D. Steelhead Mobile transparently tunnels traffic but requires in-path appliances at branches only. Answer. Correct answer. B. Explanation. To optimize mobile-originated traffic, both ends must participate. Specific is Steelhead. Physical or virtual, including SOS accelerator, must be present on the cloud side to interact with Steelhead Mobile. Interceptors aren't required per ISP. COS isn't necessary for deduplication. Branch appliances don't affect remote mobile users. The concept endpoint pair needed for optimization. Question 6. Despite the fact that Steelhead appliances monitor performance, Octagomez is resolving an intermittent performance degradation that only occurs when large file transfers overlap with VoIP sessions. What conceptual tool or practice would most efficiently isolate and remedy the issue? A. Use CLI commands to generate packet captures across both flows simultaneously. B. Apply COS policies to prioritize VoIP traffic and deprioritize file transfer flows. C. APHEP optimization to reduce file transfer bandwidth. D. Deploy an additional Steelhead to split traffic. Answer. Correct answer. B. Explanation. Applying COS to prioritize latency-sensitive VoIP while relegating bulk transfers ensures critical traffic isn't delayed or dropped. CLI captures are diagnostic but don't solve the conflict. HEP optimization doesn't affect file types like FTP or sys generically. Adding appliances doesn't inherently resolve contention. The concept, resource allocation via COS. Question 7. Based on the information that a Steelhead pair is deployed behind an interceptor for high availability, Lucas is evaluating failover behavior. What principle underlies seamless traffic continuation if one Steelhead fails? A. The interceptor uses VIPs and health check to redirect flows to the surviving appliance. B. Steelhead appliances share state via regularly synchronized sessions during clustering. C. In-path fallback ensures traffic bypasses to an alternate routing path automatically. D. The surviving Steelhead takes over the IP of the failed unit instantaneously. Hot swap. Answer. Correct answer. A. Explanation. Interceptors manage load balancing and high availability by monitoring Steelheads' health and using virtual IPs, VIPs to redirect traffic transparently to healthy units. Steelheads don't share session state. If sessions may need re-optimization, there's no automatic fallback path routing. Surviving units don't assume failed unit IP. Instead, interceptor handles traffic redirection via VIP. Question 8. Considering the evidence that Riverbed's protocol optimization mechanisms vary by protocol, which conceptual difference explains why CIFS optimization yields larger gains for small metadata operations than for bulk file reads? CIFS optimization uses metadata caching, e.g., directory listings and pipelining to reduce RTTS on metadata, whereas bulk reads are already done in large chunks. B. Bulk reads are already compressed by the client, so there's little to optimize. C. Metadata operations don't benefit from deduplication, but bulk reads do. D. Bulk reads only traverse Steelhead Mobile channels where optimization is disabled. Answer. Correct answer. A. Explanation. CIFS optimization is especially effective for metadata, e.g., directory traversals by caching directory contents and pipelining requests to reduce round-trip delays. Bulk reads are transferred in larger contiguous blocks, offering less room for further optimization. Client compression isn't assumed. Metadata may still benefit from dedupe, but latency wins are more dramatic. Mobile channel restriction D. Irrelevant here. Question 9. To what extent does the deployment of Steel Central Controller enhance management in a mid-sized enterprise? Conceptually, why might it be preferred over managing each Steelhead individually via CLI? A. It provides centralized policy definition monitoring dashboards and alerting across all appliances. B. It proxies traffic for optimization, reducing load on steelheads. C. CLI configuration is deprecated in modern Riverbed deployments. D. It automatically updates firmware over the WAN without admin intervention. Answer. Correct answer. A. Explanation. The Steel Central Controller centralizes administration, unified dashboards, policy templates, aggregated monitoring, and alerting, providing consistency and reducing overhead compared to individual CLI management. It doesn't proxy traffic or reduce appliance load. CLI remains supported. Firmware updates require admin decision, not fully automatic. Question 10. When analyzing a complex network environment where branch office traffic is redirected OEIT, a steelhead cluster ISTA only realizes that after an intermittent outage, only one of two steelheads resumes optimization. The other remains idle, although it's healthy. Conceptually, what should ISTA only verify to restore balanced utilization? A. Ensure both steelheads are configured with identical P7 group and priority settings. B. Restart both appliances so EP load sharing resets. C. Enable COS on the WAN to ensure equal traffic distribution. D. Replace the interceptor as load balancing isn't handled properly. Answer. Correct answer. A. Explanation relies on proper service group and priority configuration on each steelhead to balance traffic. If one has mismatched settings, traffic may only go to a specific appliance even if both are healthy. Restarting might temporarily help but doesn't resolve config drift. COS doesn't for EP load balancing. No interceptor involved. EAB environment. Question 11. Demonstrated by a regional healthcare provider with strict data compliance needs is Al Mansouri is implementing Riverbed optimization between data centers. Due to regulatory concerns, she is hesitant about enabling SSL optimization. What should she consider when evaluating Riverbed's SSL optimization capabilities? A. SSL optimization requires external third-party certificates and increases risk of credential leakage. B. Steelhead can optimize encrypted SSL only after SSL certificates are imported and peer trust is established. C. SSL optimization is automatically applied on an HE so traffic once detected. D. SSL optimization does not store private key data and thus cannot be used for enterprise applications. Answer. Correct answer. B. Explanation. Steelhead's SSL optimization requires administrators to import SSL certificates into the appliance to perform lawful decryption and re-encryption as split proxy. Trust must be established between appliances. This is secure and auditable if implemented properly. SSL optimization is not automatic, and options A and D misrepresent functionality. Riverbed fully supports compliance-aware SSL optimization. Question 12. Throughout the course of a data backup routine, ISTA Ortega observes that nightly large data transfers consume most of the WAN bandwidth, impacting business-critical application performance. Which Riverbed concept would be most effective in proactively preventing performance degradation? A. Use NetFlow to divert backup traffic to off-peak hours. B. Configure COS on Steelhead to deprioritize backup jobs. C. Set HTTP optimization rules for all internal traffic. D. Enable latency-based forwarding on Steelhead to split traffic. Answer. Correct answer. B. Explanation. COS ensures traffic prioritization by classifying flows and reserving bandwidth for critical apps. Backup jobs can be tagged low priority so real-time traffic like VoIP or ERP apps maintain performance. NetFlow is for monitoring, not traffic shaping. HTTP optimization doesn't apply to backup protocols. Latency-based forwarding is not Riverbed traffic splitting method. Question 13. With respect to remote users connecting over VPN, Svensson is deploying Steelhead mobile clients to optimize SOS performance. She notices no performance improvement. What is the most probable conceptual reason? A. Steelhead mobile must bypass the VPN tunnel to apply optimization. B. Steelhead mobile cannot optimize encrypted SOS traffic. C. A cloud-end Steelhead or SOS accelerator must also be deployed to complete optimization. The VPN encryption prevents the use of TCP window scaling. Answer. Correct answer. C. Explanation. Steelhead mobilely optimizes traffic when the remote end is also equipped with a Steelhead or Riverbed SOS accelerator. Without that optimization handshake phase, VPN encryption is handled at lower layers and doesn't inherently block TCP optimization. Steelhead mobile supports optimization within tunnels, but corresponding peer is critical. Question 14. In light of recent developments, Ista Ibrahim is analyzing the performance of MAPI protocol-based email applications across a WAN. While latency and packet loss are low, email is sluggish. Which protocol-specific Riverbed feature should be investigated? A. CIFS optimization with directory prefetch. B. MAPI read-ahead and connection multiplexing. C. HEP pipelining with ECP multiplexing. D. SSL optimization with session reuse. Answer. Correct answer. B. Explanation. MAPI optimization includes advanced features like read-ahead, prefetching attachments, and connection multiplexing to reduce protocol chatter over WANs. HET SSL optimization are unrelated to Outlook or Exchange traffic. Riverbed provides deep protocol support to eliminate protocol-induced latencies, even in low-loss conditions. Question 15. By evaluating the challenges of deploying Steelheads in hybrid WAN environments using SD-WAN and MPLS links, Ista Nakamura wants consistent optimization across all paths. Which deployment model best ensures transparent optimization regardless of WAN transport? A. In-path deployment of both MPLS and Internet edges. B. Out-of-path deployment using policy-based routing PIA. B. Redirection with separate configurations per circuit. D. In-path virtual Steelheads deployed in overlay fabric with dynamic peering. Answer. Correct answer. D. Explanation. In hybrid networks, deploying virtual Steelheads in overlay fabrics allows dynamic peering and optimization over any linky. G. MPLS dia. This enables path-agnostic optimization. Traditional in-path may not be feasible due to path diversity are manual and brittle in hybrid networks. Riverbed's SD-WAN support integrates best with dynamic models. Question 16. The underlying principle of Riverbed diduplication implies efficient identification of redundant data. Ista Mensa notices diduplication benefits are low for certain video surveillance traffic. Why is optimization ineffective? A. Video files are encrypted and compressed before transit. B. Steelhead cannot optimize files larger than 100 megabytes. C. Video traffic cannot be routed via the interceptor appliance. D. COS is required before deduplication is enabled. Answer. Correct answer. A. Explanation. When data is encrypted and compressed before reaching Steelhead, content fingerprinting fails. Blocks look unique even if data is redundant. That's why video, especially H.264 and encrypted streams, don't deduplicate well. File size limits don't exist like in B. Interceptors aren't involved in deduplication and COS is not prerequisite. Question 17. Upon closer examination, D'Souza observes that optimization ratios drop after new software version is deployed across distributed retail network. Files are now transferred in compressed formats. What is sound explanation based on Riverbed optimization mechanics? A. Compressed files contain high redundancy that Steelhead can now detect. B. Compression disables protocol optimization for CIFS and MAPI. C. Compression decreases pattern redundancy, reducing deduplication effectiveness. D. Steelhead require or optimize compressed data. Answer. Correct answer. C. Explanation. Compression alters bit patterns, even for redundant content, reducing block recognition by Steelhead's SDR engine. Therefore, deduplication benefits diminish when already compressed content. The IPPG is transferred. Protocol optimization still works but has reduced IMP via redirection mechanism, not requirement for compression handling. Question 18. Contrary to popular belief, this DU assumes interceptor appliances optimize traffic for load balancing. What is the actual function of an interceptor within the Riverbed ecosystem? A. It terminates TCP flows and applies deduplication. B. It redirects flows to Steelheads based on load or availability. C. It enhances COS tagging across Steelheads. D. It is used only in cloud deployments. Answer. Correct answer. B. Explanation. Interceptor appliances monitor flow availability and health check steelheads to redirect TCP connections based on capacity or failures. They do not perform optimization or deduplication. Cost tagging is managed on steelheads. Interceptors are primarily for scale-out and high availability scenarios, not limited to cloud. Question 19. From a practical standpoint, is Danvers using the Riverbed CLI to check appliance health? She issues the show stats connection command. Which of the following best describes the conceptual benefit of this command? A. It lists global system EPU and memory usage. B. It provides detailed flow statistics including peer optimization status. C. It displays historical bandwidth savings charts. D. It confirms cost class hierarchy for ongoing flows. Answer. Correct answer. B. Explanation. Show stats connection reveals optimized and pass-through flows, connection details, peering, direction, and deduplication stats. It's essential for troubleshooting. EPU and memory stats are in show memory or show process. Cost classification uses different commands. Historical bandwidth is seen in GUI or show stats WAN. Question 20. To better understand how Riverbed handles asymmetric routes, Istaricta deploys steelheads across dual WAN links. Some sessions aren't optimized. What must he ensure for optimization to occur across both directions? A. Enable TCP pass-through mode for partial optimization. B. Configure peering rules so steelheads can identify reverse flows. C. Switch to virtual steelhead deployment in WAN core. D. Disable deduplication to avoid asymmetric optimization errors. Answer. Correct answer. B. Explanation. Steelheads rely on bidirectional visibility to complete optimization. If asymmetric routing causes flows to return via a different path, peering rules, e.g., fixed target rules or auto-discovery, must guide appliances to find each other. Pass-through disables optimization. Virtualization doesn't address path asymmetry directly. Disabling deduplication undermines optimization. Question 21. Under the assumption that a multinational corporation is deploying steelhead appliances across data centers connected by links with high jitter and occasional packet loss, Mr. Jensen needs to ensure consistent application acceleration. What feature should he prioritize to mitigate the impact of jitter on TCP performance? A. TCP selective acknowledgements (SAC) to handle out-of-order packets. B. Application acceleration profiles tailored to based applications. C. Enable TCP fast retransmit and retransmission timeout tuning. D. Deploy interceptor appliances to buffer jitter effects. Answer. Correct answer. C. Explanation. TCP fast retransmit and retransmission timeout tuning reduce delays caused by jitter and packet loss by quickly resending lost packets before the timeout expires. SAC improves loss recovery but doesn't directly mitigate jitter impact on timing. Application acceleration profiles focus on specific app behavior, not jitter. Interceptors handle load balancing, not jitter buffering. Question 22. When faced with a hybrid cloud environment where users access SOS applications through multiple ISP links, Chowdhury wants to ensure end-to-end optimization. Which conceptual deployment choice best supports this goal? A. Deploy Steelhead SOS accelerators in the cloud and Steelhead mobile on endpoints. B. Use interceptor appliances at ISP edge routers for traffic shaping. C. Enable out-of-path deployment for all remote sites. D. Configure Steel Central Controller to proxy all SOS traffic. Answer. Correct answer. A. Explanation. Steelhead SOS accelerators in the cloud and Steelhead mobile clients on endpoints form an optimization pair to accelerate SOS traffic effectively. Interceptors don't shape traffic and out-of-path deployment is unrelated to SOS endpoint optimization. Steel Central Controller manages devices but doesn't proxy traffic. Question 23. In comparison with traditional WAN links, Ista Silva is considering using Riverbed's virtual Steelhead solutions in an SDN environment. What conceptual advantage does virtual Steelhead appliance provide? A. Greater hardware acceleration and encryption offload. B. Dynamic scalability and integration with virtualized cloud infrastructure. C. Bill-of-B e-direction without additional configuration. D. Automatic deduplication without manual tuning. Answer. Correct answer. B. Explanation. Virtual steelheads integrate seamlessly with cloud and SDN environments, enabling dynamic scalability and flexible deployment without physical constraints. Hardware acceleration is typically less than physical steelhead requires separate configuration. Deduplication requires tuning regardless of appliance type. Question 24. Considering the evidence that steelhead appliances perform inline optimization, Kim is concerned about appliance failure modes. Which behavior best describes a properly configured steelhead in path fail open mode? A. The appliance drops all traffic until manually restarted. B. Traffic bypasses the steelhead to avoid network disruption. C. Traffic is duplicated and sent simultaneously through the steelhead and direct path. D. Steelhead automatically reroutes traffic via an interceptor. Answer. Correct answer. B. Explanation. In fail open mode, if the steelhead fails, traffic bypasses the appliance, so the network remains functional, albeit unoptimized. Dropping traffic causes outages. Traffic duplication is not a standard failover method. Interceptors manage load balancing but aren't automatic route tools for fail open. Question 25. During the process of troubleshooting application slowness, Chen notices that some TCP connections are not being optimized despite being routed through steelheads. What is the most likely conceptual cause? A. The traffic matches an in-path exclusion or bypass rule. B. Steelhead is overloaded and dropping optimization. C. Cost prioritization is suppressing deduplication. D. SSL decryption is enabled but certificates are missing. Answer. Correct answer. A. Explanation. Bypass or exclusion rules intentionally prevent optimization of certain traffic, e.g. non-WAN traffic or sensitive flows. Overload might cause performance drops, but not selective non-optimization. Cost doesn't suppress deduplication. Missing SSL certificates prevent SSL optimization, but traffic is usually still optimized if non-encrypted. Question 26. In a modern context of deploying steelhead appliances within complex network topologies, Laurent needs to optimize CIFS traffic where multiple SMB versions are in use. Which Riverbed optimization approach best addresses performance across SMB and SMB? A. Disable CIFS optimization and rely on TCP enhancements only. B. Enable protocol-specific optimization supporting multi-version SMB negotiation. C. Use generate HTTP acceleration profiles for all SMB traffic. D. Force all clients to SMB for compatibility. Answer. Correct answer. B. Explanation. Riverbed supports advanced protocol optimization that adapts to multiple SMB versions, enhancing performance by understanding version negotiation and specific protocol behaviors. Disabling CIF removes key gains. Acceleration is irrelevant. Forcing SMB is insecure and deprecated. Question 27. For many years, Walker has used CLI tools to configure steelhead appliances. She's now considering the benefits of the management console. Which conceptual advantage does the management console provide over CLI? A. Centralized multi-device monitoring and simplified policy deployment. B. CLI commands run faster and support all advanced features. C. Management console disables the need for appliance firmware updates. D. CLI is deprecated in current Riverbed solutions. Answer. Correct answer. A. Explanation. The management console provides centralized visibility and control over multiple appliances with GUI-based configuration and monitoring, easing management complexity. CLI remains fully supported and sometimes preferred for granular control. Firmware updates require admin approval. CLI is not deprecated. Question 20. Within the framework of ensuring data security on steelhead appliances, Fernandez is implementing hardening best practices. Which practice conceptually enhances security most effectively? A. Disable all logging to avoid data leakage. B. Enable role-based access control, RBAC, and encrypt management interfaces. C. Allow anonymous SMP read to simplify monitoring. D. Disable SSL optimization to reduce attack surface. Answer. Correct answer. B. Explanation. RBAC limits user privileges to reduce insider risk, and encrypting management access protects credentials and sessions from interception. Disabling logs reduces forensic ability. Allowing anonymous SMP is a security risk. SSL optimization doesn't impact appliance security directly. Question 29. To determine whether a particular steelhead deployment is achieving expected optimization gains, is Rossi reviews management reports showing bandwidth savings and deduplication ratios. What conceptual factors should she consider in interpreting these metrics? A. Higher deduplication always means better user experience. B. Optimization ratios depend on traffic type, redundancy, and protocol behavior. C. Cost configurations are relevant to bandwidth savings. D. Deduplication ratios correlate directly to EP utilization. Answer. Correct answer. B. Explanation. Optimization depends on traffic characteristics. Repetitive, compressible content yields higher savings. Some protocols optimize better than others. Cost can affect throughput but doesn't directly impact dedupe ratios. CPU depends on processing load, not strictly deduplication ratios. Question 30. Examining the consequences of deploying steelhead appliances with asymmetric routing, Mr. O'Connell wants to maintain full bidirectional optimization. Which design principle should he follow? A. Ensure symmetric routing or implement static peering and consistent traffic redirection rules. B. Disable TCP optimizations and rely on application acceleration only. C. Deploy multiple interceptor appliances per path to handle asymmetry. D. Use out-of-path deployment exclusively. Answer. Correct answer. A. Explanation. Steelhead requires visibility of both flow directions to optimize properly. Symmetric routing or static pairing with consistent redirection ensures appliances see full sessions. Disabling TCP optimization reduces benefits. Multiple interceptors do not solve asymmetry. Out-of-path deployment doesn't inherently solve asymmetric flows.